Hi guys, so we're going to look at acceleration, but taking into account gravity as the acceleration. So acceleration due to gravity is negative 9.8 meters per second squared. So obviously, things falling, that's what we're going to look at. When there's no air resistance, all objects fall with the same acceleration regardless of their masses. So these are going to ignore air resistance as things are falling. So, like throwing something up and then letting it fall down or catching it. At the very top of its path, the ball's velocity is 0, but the acceleration is still negative 9.8 meters per second squared at every point, both when it's moving up and when it's moving down. To the right, you see a velocity and time graph, which we'll get into after this lecture, after this topic. So here are the different formulas for acceleration, which we have been talking about. You can see that we still have the delta V over delta T, so VF minus VI, etc. And these are the three on the bottom are from the last lecture. However, we have a new one we're going to add, and that's final velocity squared equals initial velocity squared plus 2 times acceleration times delta x, or displacement. This also can be used with problems that don't necessarily include gravity as well. So a way to help with this is that acceleration can be due to gravity, so then it'll be negative 9.8 meters per second squared, or any other acceleration. So a camera is dropped off the rim of a 239 meter high cliff. How long will it take the camera to reach the ground? What will the velocity of the camera be when it hits the ground? So I bolded and highlighted dropped because if something is dropped or falls from without actually throwing it down, that means my initial velocity is going to be 0 meters per second. Off the rim of a 239 meter high cliff. So you know that's going to be your distance but how can we make it our displacement? So delta x equals xf minus xi. So if it's 239 meters at the top, which is my initial, my final velocity, my final position is when it hits the ground, and that's going to be 0. So my delta x is negative 239 meters. Acceleration, this is dropping due to gravity, so negative 9.8 meters per second squared. How long will it take to hit the ground? So that's delta t, my time. So based on these four variables, I need to pick my correct formula. So delta x equals vi times delta t plus, half a times time, and that squared. So luckily for us, vi is 0. My initial velocity is 0. So 0 times time is going to be 0. So exit this out. We don't have to worry about this because it's 0 times the time. So this is gone. I'm going to rearrange the last part really quick. So so delta x equals a times time squared divided by 2. I just kind of put the 2 underneath because it's multiplied it across. So I'm trying to find delta t. So to get delta t by itself, I need to multiply by the reciprocal of a over 2 on both sides. This cancels out my 2's and my a's on the right side. So I'm left with 2 delta x over a equals delta t squared. The reason why I put it around it like that is just to remind you that what you're squaring is the change in time. So now, how to get rid of a square? I got to take the square root. So now, the square root of 2 times negative 239 divided by negative 9.8 equals my delta t. Delta t, when I do all of that, it's going to equal 6.98 seconds. So For it to hit the ground, it will take 6.98 seconds. That's the first part of the question. So I'm going to erase all of this. Well, I guess I can just erase my work, and I'm going to put my answer right here. So this was the first part. That's the first answer. Go and erase all of this. Give me a few minutes, or a few seconds, hopefully. Very good. So what will the velocity be when it hits the ground? So this has to be my final velocity. That's what I'm trying to find. I can do different colors, so I don't know which one, but it's fine. Yeah, that's fine. So I have a final velocity, an initial velocity, I have an acceleration, I have a time. I'm gonna use this time. I need to find this before I can actually solve it. And I have a delta x. But so the equation we can use is actually final velocity equals initial velocity plus acceleration, times time, change in time. Well, lucky for us again, this is going to be 0 because it's dropped off. Therefore, the initial velocity is 0. So VF equals A, so negative 9.8 meters per second squared, times my time. I end up with negative 68.4 meters per second. And why am I not using my 9.8 seconds or 9.8 for my sig figs? It's because it's a constant, and you're not going to use that for your sig figs. You're going to use the number given in the problem, so it's 3 sig figs.